Hello everybody, welcome to our video solution to problem 1 from Quiz 4. This is Fall 2023, Math 307, Linear Algebra at Cal State Fullerton. And in this problem, we're given a linear map T from V to W, so we, as usual, assume that V and W are vector spaces over some field F. And we're going to assume that the null space of T, so this is this bit here, the null space of T is the zero subspace. So let's just briefly recall what the null space is. So the null space of a linear map, sometimes called the kernel, is going to be all elements of the domain, which in this case is V. So all V and V, such that the T image of V is equal to the zero element in the codomain W. All right, so usually we're not going to write this W down here, but okay, maybe this video I'll do it just to make sure we're all understanding what zero we're talking about. All right. By the way, like which zero is this up here, right? Well, that's actually the zero in the vector space V, right? Because the null space is a subset of V. And our goal in this problem is to prove that T is injective. So this is one of the really nice uses of the null space is it detects injectivity. If the null space is just the zero subspace, then your linear map is injective. So let's see if we can prove that. So to show that T is injective, we're going to take two elements of V that have the same image and show that those have to be the same element. So we're going to let, say, U and V be in the vector space V, such that TU and TV are equal. Okay, so U and V have the same image. This shouldn't happen with an injective function unless U and V are the same. So that's our goal, all right? So our goal is to show that U is equal to V. All right, but now because TU is equal to TV, well, what if I subtract? All right, of course, by subtract, I mean add the additive inverse. That tells you that TU minus TV is going to equal 0. But now I have T of a difference. Of course, this is kind of very similar to T of a sum. I can pull the T out. Why? Because I'm working with a linear map, right? So this is because T is linear. But T of U minus V equaling 0 tells me that U minus V is in the null space. Right? That's what it means to be in the null space, is your T image is 0. All right, and of course, remember, this is the 0 in W. But the null space of T, by assumption, is just the 0 element in the vector space V. And so we conclude that U minus V is equal to the 0 element. Okay, let's add V on both sides. And I get U is equal to V. Hey, that was our goal, right? We wanted to show if I had two elements with the same T image, they actually had to be the same element. And this implies that T is injective. So there we go. All right, everybody, we'll see you next time.